Hello everyone, welcome to Brain Blitz Audios. In today's episode of Cbse Board Exam, we'll be looking at previous year questions of mathematics in Cbse Board Exam. The chapter that we'll be dealing with is three-dimensional geometry. This is the 11th chapter in the grade 12 syllabus for Cbse. Now this continues our videos on three-dimensional geometry and other chapters in Cbse Board Exam. So if you want to view the earlier videos, please click the link in the description down below. And don't forget to watch the video entirely because we have a very important question at the end of this video. Let's begin with the first question, right? Here it is. A plane makes intercepts -6, 3, 4, respectively on the coordinate axes. Find the length of the perpendicular from the origin on it. So let's begin with the question. So a plane makes an intercept, and the coordinates of the intercept is -6, 3, and 4. So let's write the equation of the plane in intercept form. And that is x by a plus y by b plus z by c is equal to 1. So when plugging in the values, we'll get x by -6 plus y by 3 plus z by 4 is equal to 1. Now, in the question, we need to find the perpendicular distance between the plane and the origin, whose coordinates are 0, 0, 0. So here we use distance between a point and a plane. So we use the formula d is equal to ax plus by plus cz minus d whole divided by a square plus b square plus c square the whole root, and it is entirely under a modulus. So this is the formula. But what is a, b, c, d, and small d? So here a is equal to -1/6. B is equal to 1/3. Capital C is equal to 1/4. And capital D is equal to 1. Let's plug in the values, right? Here we go. Distance D is equal to -1/6 into x is 0, plus 1/3 into y is 0, plus 1/4 into z is 0. And the reason why it's 0 is that x, y, z are the coordinates of the point, and the point is the origin. And minus d, the value of d is 1. Whole divided by 1/6, the whole square, plus 1/3, the whole square, plus 1/4, the whole square, and which is under a root. So the first three parts, that is -1/6 into 0, 1/3 into 0, and 1/4 into 0 are equal to 0, because 0 multiplied by any number is equal to 0. So the numerator remains -1. Whole divided by 1/6 the whole square is 1/36, plus 1/3 the whole square is 1/9, plus 1/4 the whole square is 1/16, the whole root. And this is under a big modulus. So in the modulus sign, whatever is present is given as the positive sign of it. So here -1 would become +1 due to the modulus function. And divided by, we need to find an LCM for the three denominators in the root. So we can use 144, because when you divide 9 by 144, so that is 9, 5, 54, 6, 54, 0. So 144 divided by 9 gives you 16. And so 144 divided by 16 would give you 9. And 144 divided by 36 would give you 4. So now let's plug in the values. So the whole denominator is 144. So 36 times 4 is 144. So 4 goes in the numerator. 16 times 9 is 144. So 16 goes into the numerator of the second one, and 9 goes into the numerator of the third one. And everything is under a root. And 4 plus 16 plus 9 gives you 29. Root 29 by 144. And that is the denominator. The numerator is still 1. Now, the square root of 144 is equal to 12. So it'll be 1 by root of 29 divided by 12. And so the distance d will be equal to 12 by root 29 units. That is our answer. Next question. Show that the lines phi minus x by minus 4, y minus 7 by 4, and z plus 3 by minus 5, and x minus 8 by 7 is equal to 2y minus 8 by 2 is equal to z minus 5 by 3 are coplanar. So as you can see, these lines are not in their standard forms, so we need to convert them to their standard forms. The standard form of the first line is x minus 5 by 4 is equal to y minus 7 by 4 is equal to z plus 3 by minus 5. And the second line has the standard form x minus 8 by 7 is equal to y minus 4 by 1 is equal to z minus 5 by 3. So now on comparing with the standard form, which is x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c, we'll get the value of x1 as 5, y1 as 7, z1 as minus 3, a as 4, b as 4, and c as minus 5. So we're taking all of these values from the first line. And the second line contains x2 is equal to 8, y2 is equal to 4, z2 is equal to 5, and a2 is equal to 7, b2 is equal to 1, and c2 is equal to 3. Now let's put in the condition for two lines to be coplanar. So for two lines to be coplanar, they should satisfy the condition x2 minus x1, a1, a2, y2 minus y1, b1, b2, z2 minus z1, c1, c2 is equal to 0. So the determinant of this must be equal to 0. Then these two lines are coplanar. So on the LHS, let's plug in the values. x2 is 8, minus x1 is 5, y2 is 4, minus y1 is 7, z2 is 5, minus z1 is minus 3, so 5 minus minus 3 becomes 5 plus 3, and a1 is 4, a2 is 7, b1 is 4, b2 is 1, c1 is minus 5, c2 is 3. So now let's solve the top row. So we'll get 3, 4, 7, minus 3, 4, 1, 8, minus 5, 3. And now let's solve it. So we're expanding. What we're doing is we're expanding the determinant along the first row. This kind of operation we've done in the chapter determinants. So let's do it. Plus 3 into 4 into 3 minus of 1 into minus 5 minus of minus 3 into 4 into 3 minus 7 into minus 5 plus 8 and then 4 into 1 minus 7 into 4. Let's simplify that. 4 into 3 is 12 minus 1 into 5 is minus 5. So 12 minus of minus 5 gives you 12 plus 5. And minus of minus 3 is plus 3. And then 4 into 3 is again 12. And then 7 into minus 5 is minus 35. So 12 minus of minus 35 is 12 plus 35. Plus 8 times 4 into 1 is 4. Minus 7 into 4 is 28. So 3 times 17 plus 3 times 47 plus 8 times minus 24. 3 times 17, let's do it. 10 threes are 30, 7 threes are 21. So 17 threes are 51 plus 47 times 3. So 43s are 120, 7 threes are 21, 141 plus 24 times 8. So 28's 160, 4 8's are 32, 192. So it'll be minus of 192. So 51 plus 141 will be equal to 192. So 192 minus 192 is equal to 0, which is equal to the RHS. So we have proved that the given lines are coplanar, which is what we were asked to show. We were asked to show that the lines were coplanar, and we did that by using the condition for coplanarity. And putting in the values, we got the value 0, which proves that the given lines are coplanar. Now let's move on to the final question. Find the vector equation of the plane which contains the line of intersection of the planes, and we have two equations here, and which is perpendicular to the plane, and we have a third plane here. So in any question of planes, it is better to convert all of the equations of the planes into their Cartesian forms. So plane 1 can be written as x plus 2y plus 3z minus 4 equals 0. And the second plane can be written as 2x plus y minus z plus 5 is equal to 0. And the third plane can be written as 5x plus 3y minus 6z plus 8 equals 0. So let's write them down. Plane 1 and plane 2. So we need to find the equation of the plane which contains the line of intersection of the planes. So the plane in our question passes through the intersection of the planes x plus 2y plus 3z minus 4 is equal to 0 and 2x plus y minus z plus 5 is equal to 0. So the equation of a plane passing through plane 1 and plane 2 will be equal to plane 1 plus lambda times plane 2. let's plug in the values. So it will be x plus 2y plus 3z minus 4 plus lambda times 2x plus y minus z plus 5 is equal to 0. Let's take this as our equation 1. So now let's convert this equation in the terms of lambda. So we're going to be writing each x component, y component, and z component separately. So let's take x outside. So in both the equations, the left side has x as 1, and the right side has 2 lambda. 1 plus 2 lambda plus y times 2 plus lambda, 1 lambda, that is lambda, and plus z times left side is 3, right side is minus 1 into lambda, so 3 minus lambda. And the constants, let's write them as they are. So minus 4 plus 5 lambda is equal to 0. So both equations are the same. So now let's write these as A1, B1, and C1. So in our question, the vector equation of the plane which contains the line of intersection of the two planes is perpendicular to a third plane. So equation 1 is perpendicular to the plane 5x plus 3y minus 6z plus 8 equals 0. Let's take 5 as capital A2, 3 as capital B2, and minus 6 as capital C2. So plane 1 is perpendicular to the plane 5x plus 3y minus 6z plus 8 equal to 0. So for two planes to be perpendicular, the condition is A1, A2 plus B1, B2 plus C1, C2 is equal to 0. Let's plug in the values. A1 is 1 plus 2 lambda, A2 is 5, plus B1 is 2 plus lambda, B2 is 3, plus C1 is 3 minus lambda, C2 is minus 6, is equal to 0. Let's plug in the values. So 5 plus 10 lambda, we're just multiplying the same, plus 6 plus 3 lambda, plus 6 lambda minus 18 is equal to 0. It's just a multiplication of the previous step. And let's group the lambda terms together. So lambda times 10 plus 3 plus 6, and then plus the constants are 5 plus 6 minus 18 is equal to 0. So therefore 10 plus 3 plus 6 is 19 lambda, plus then 5 plus 6 is 11. 11 minus 18 is minus 7. So 19 lambda minus 7 is equal to 0. So 19 lambda is equal to 7. Lambda is equal to 7 by 19. So now we put lambda is equal to 7 by 19 in our equation 1. So remind you, the equation 1 is this. So we should put the lambda value right here and not in the below equation. It would just complicate stuff. So put it in equation 1. Should we write equation 1? Yes, we do. So x plus 2y plus 3z minus 4 plus, we put the value of lambda as 7 by 19 times 2x plus y minus z plus 5, and then it is equal to 0, the right hand side. Now let's split into x, y, and z components. So x into 1 plus 2 times 7 by 19, that is 14 by 19, plus y into 2 plus 1 into 7 by 19, that is 7 by 19, plus z into 3 minus 1 into 7 by 19 is minus 7 by 19. And then plus minus 4 plus 5 into 7 is 35 divided by 19 is equal to 0. Okay, now it's the final step. Let's simplify the brackets. So 1 plus 14 by 19 will be equal to 19 plus 4 divided by 19 plus 14 divided by 19. So that is 33. 33 by 19x plus 2 plus 7 by 19. So 19 times 2 is 38. 38 plus 7 is 45. So 45 by 19y plus 19 times 3. So 9 3s are 27. 1 3 is a 3. 3 plus 2, 5. So that's 57. 57 minus 7 is equal to 50 divided by 19, and then z. And the constant is minus 4. So 19 times 4 is 76. So minus 76 plus 35 will be equal to minus 41 divided by 19 is equal to 0. So let's take 1 by 19 out. So it's 33x plus 45y plus 50z minus 41 is equal to 0. So let's take 1 by 19 to the right-hand side. So 19 times 0 will still be 0. So our equation is 33x plus 45y plus 50z minus 41 is equal to 0. However, don't be happy just yet. This is the Cartesian equation. And the question is asking us to find the vector equation. So convert this into a vector equation. So it'll be r dot vector r dot 33i plus 45j plus 50k, and then close the bracket, will be equal to 41. So this is the required answer. Now in some answer keys, they'll give you minus 41 equals 0. It is still the same. So this is the vector equation that you should be getting. So we've converted the vector equations in the initial step to Cartesian and solved it using the Cartesian equations, which is pretty easier than the vector equations. And finally, we got the required Cartesian equation and we converted it to the right answer, which is a vector equation. So that completes this episode of CBSE board exams. So there are a lot of questions from 3D geometry in CBSE board exams. So we have a lot of videos about it in our playlist CBSE board exam. I'll be providing some in the description down below. Be sure to click those links and get access to those content. And if you want to be a part of our channel, which is Brain Blitz Audios, then please subscribe to our channel. Hit the notifications button to receive more of our useful and interesting content, such as learner words, mind maps, NEET preparation, etc. We also have a new playlist called Memory Hacks about how to develop a superpower memory. So be sure to check it out as well in our channel. And therefore, until the next episode, take care, stay safe. Bye-bye for now.